This video is going to review the mole concept, basic mole conversions, and basic stoichiometry calculations. First, the idea of a mole. 1 mole equals 6.02 times 10 to the 23rd particles. Mole is a word that means a number, just like the word dozen means 12. Mole means 6.02 times 10 to the 23rd. This number is called Avogadro's number. Avogadro himself didn't figure out this number, but he figured out the relationship that eventually led other scientists to calculate this number, so it's named in Avogadro's honor. Remember that the word particles is a generic term. There are more specific names for the representative particle depending on what type of substance you're discussing. The representative particle of an element is more specifically called an atom. For molecular compounds, you call the smallest particle a molecule. And for ionic compounds, you call it a formula unit. 1 mole of a substance also equals that substance's molar mass, measured in grams. The molar mass of any substance is the sum of the masses of all the atoms present in 1 unit. Atomic masses, of course, are found on the periodic table. To calculate the molar mass of a compound, you add up the atomic masses of all the atoms that are present. So for NaCl, you'd add the mass of 1 Na and 1 Cl. 22.99 plus 35.45 gives you 58.44 grams per mole. You would do the same thing for CaCl2. You'd need the mass of 1 Ca, 40.08, and the mass of 2 Cls. Add all this together and you get 110.98. In this last example, make sure you remember to distribute the subscript to every element inside the parentheses. So in Fe, NO3, 2, you have 2 nitrogens and you have 6 oxygens. To calculate the molar mass of this compound, you added the mass of 1 Fe, 2 nitrogens, and 6 oxygens together to get 179.87. Our third relationship only applies to gases at STP. For these things, 1 mole equals 22.4 liters. That means 1 mole of any gas at STP takes up 22.4 liters of space. Remember, STP stands for standard temperature and pressure. These are actual numbers. Standard temperature is 0 degrees Celsius, which is the same thing as 273 Kelvin. Standard pressure is 1 atmosphere, 101.3 kPa, 760 millimeters of mercury, etc. You must know these 3 relationships. You should know them from Chem 1. If any of them have slipped out of your mind, make sure you have them in your head now. Let's do an example. This first question asks you to calculate the number of molecules in 60 grams of NO2. Always start with the number you're given. So in this case, we're going to start with 60.0 grams NO2. We need to convert grams to moles, then we can convert from moles to molecules. To convert from grams to moles, of course, we'll need the molar mass of this compound. We'll need that to be on the bottom so that grams will cancel. The molar mass of NO2 is 46.01 grams. The molar mass of a compound, by definition, is equal to 1 mole of that compound. Now we can do a second conversion. We can put moles on the bottom and we can convert on top using 6.02 times 10 to the 23rd. That's the number of particles, any type of particle, in this case molecules. To solve, we multiply the numbers on top, we divide what's on bottom, and in this case the answer comes out to be 7.85 times 10 to the 23rd molecules of NO2. Let's look at one more example. This one wants you to calculate the mass of 18.0 liters of CH4 gas at STP. Again, you always start by writing down the number and the unit and the substance that's given. So in this case, that's 18.0 liters of CH4. We'll always have to convert to moles first, so we're going to need liters on bottom and moles on top. 1 mole of any gas, if it's at STP, takes up 22.4 liters of space. Now we can convert from moles to what the question asks for, which is grams. We need moles on the bottom to cancel. And we need the molar mass of CH4 on top. That is 16.042 grams. And then we solve. This answer is 12.9 grams of CH4. Let's move on and talk about stoichiometry. The field of stoichiometry is the study of numerical relationships in chemical reactions. So instead of just talking about one substance and changing the units of our description, we're now talking about changing whole substances and how they're related in a chemical process that occurred. Stoichiometry is a quantitative study. It's not just a qualitative description of how the reaction looks or how the components act. It's numerical relationships. Here's our first example. It asks us to calculate the number of grams of NH3 produced by the reaction of 5.40 grams of hydrogen with an excess of nitrogen. And then it gives us our balanced chemical equation. The first thing you should always do in a stoichiometry problem is check the equation to see that it's balanced. If it's not balanced, you must do that first because you'll need those coefficients as you perform the calculation. In stoichiometry problems, make sure you write down your given number, its unit, and the formula for that substance. Because in these problems, we're going to change all those things, the units, the substance as well. You need all those pieces as you do each step of the calculation. In this example, we'll start with 5.40 grams of hydrogen. If a question gives you anything besides moles, that's your first conversion. Remember that the coefficients in the balanced equation give us a connection between the substances in terms of moles. So in this example, we know that 3 moles of hydrogen is comparable to 2 moles of ammonia. But that means if we weren't given moles in the first place, we need moles. We have to convert to moles before we can use these coefficients to convert between substances. So first we're going to convert from grams to moles by putting grams on the bottom and 1 mole on the top. The molar mass of hydrogen gas is 2.016. That is equal to 1 mole of hydrogen on top. Now we can do our mole conversion. We can put moles of hydrogen on the bottom to cancel, and we can switch that to moles of ammonia on top. This is where you go and you use your coefficients. So for NH3, the coefficient is 2. 2 moles of ammonia for every 3 moles of hydrogen gas. The last thing we need to do is to convert to the unit that we're asked for. We're not asked for moles of ammonia, we're asked for grams of ammonia. So we do our last conversion by putting moles of NH3 on the bottom its molar mass on top, 17.034. It won't hurt you to take an extra second and check what you've written to see that all your units cancel properly. If we start over here on the left, grams of hydrogen will cancel, moles of hydrogen will cancel, moles of NH3 will cancel, grams of NH3 will not cancel, and that's good because that's what we're supposed to be solving for. To solve this on your calculator, you can put all the numbers on top end together, multiplied, and then individually divide by a number on the bottom. When you do that here, the answer comes out to be 30.4 grams of NH3. This next example gives you a precipitation reaction and asks you to calculate the grams of precipitate formed. There's a couple of extra things going on in this example that we didn't have in the previous question. First, the equation is not balanced. As I said before, you must always have a balanced chemical equation when doing stoichiometry problems. Otherwise, when you get to your mole ratio step, you'll write the wrong thing. To balance this equation, you can fix your bariums by adding a 3 in front of the barium chloride. That gives you a total of 6 chlorines on the reactant side. To get 6 chlorines on the product side, you add a 6 in front of NaCl. To fix your sodiums, as well as to fix your phosphates, you put a 2 in front of sodium phosphate, and that balances everything. Another thing that's a little tougher about this question is that it doesn't simply name the substance that it wants you to solve for. This question asks you to calculate the grams of precipitate that are produced. So you have to figure out which of these products is your precipitate. This question is kind in that it gives you state symbols for everything. So you just have to be able to interpret those state symbols. If the state symbols hadn't been included, you would have had to have applied the solubility rules to determine that barium phosphate is your insoluble product. So to start our calculation, as always, we write down the number, the unit, and the formula that they give us. First, we need to convert from grams of barium chloride to moles, using its molar mass on the bottom. The molar mass of barium chloride is 208.23 grams. Now we can write our mole ratio. We can convert from BaCl2 to Ba3PO4 2. This, again, is where you use your coefficients. Barium phosphate has a coefficient of 1. Barium chloride has a coefficient of 3 after we balanced. The last thing we have to do then is convert from moles of barium phosphate to grams using its molar mass on top. The molar mass for this compound is 601.93. Grams of barium chloride cancels, moles of barium chloride cancels, moles of barium phosphate cancels, leaving us just with our grams of barium phosphate when we solve. The final answer to this question comes out to be 12.4 grams of Ba3PO4 2. One last example. This question wants you to calculate the number of liters of C8H18 needed to react with 4.78 grams of oxygen gas at STP. Balance the equation first. In this case, the balanced equation will have a 2 in front of the C8H18, 25 in front of O2, 16 in front of CO2, and 18 in front of H2O. Next, I'm going to write down 4.78 grams of oxygen. I have to convert grams of oxygen to moles using its molar mass. I need to convert from moles of oxygen to moles of what the question asks me about, which is C8H18. The coefficients for these two are included. And then this question wants me to solve for liters. So 22.4 is going to be the number I use on top. When I put all these numbers into the calculator and solve, the answer comes out to be 0.268 liters of C8H18.